In this problem, we bought one put with a strike of 40, sold one put with a strike of 45, sold one with a strike of 50, and bought one put with a strike of 55. So, and first thing we need to do, of course, is to find the time zero cash flow. That is, we paid this, we received this, we received this because we sold it, oops, the 9, and we paid the price of the last put at 55, cost 11. Now in part A, we had all call options, so we could think from left to right. And I'd said if they had been all put options, then I would be going from right to left because above the highest strike price put, all of those put options are out of the money and have zero payoff. So in this case, the highest strike price is 55. So above 55, the payoffs will be zero. The payoff at expiration will be zero for all of those puts. It's supposed to be blue. Yeah, I can try one more time. Whatever. And between 55 and 50, again thinking from right to left, we have the highest strike put option is in the money, but all of the rest of them are out of the money. And we bought, that is the put option that we paid 11 for, with the 55 strike price. We bought that, so the payoff is going to go up by $1 for every decrease of 1 in the price. So between 55 and 50, it's going to go up by 5. Sorry about that. So I'm going to just put a little dot there and connect the dots. I'm trying to go up to 5, so it should be about there. Okay, and then we sold a put option with strike of 50. So that's where it would have continued going up, going from right to left. For every dollar that we would have been gaining, now we're also losing $1 from that put option at strike of 50. So they cancel each other out, or the slope basically goes from -1 to 0. Each put option that you buy, anyway. So between 50 and 45, it's going to stay at 5. That's supposed to be at 5. And then we also, we sold a put option with strike of 45, so that's going to make it go back down because we sold it back down to 0. Our put options, the slope of the is either 0 or -1 on the put option. If we bought a put option, that actually decreases the slope by 1, so it goes from 0 to and if we sell if we sell a put option, you can see here, for example, went from 0, the slope went from 0 to -1. And when you sell a put option, it's like this, has this shape. Oh, you can't see that. When you sell a put option, the slope is either 0 or if it's below the strike price, it's a +1 slope. You see that? It's a positive slope. So it actually, when you sell a put option, actually increases the slope by 1. So here it goes from -1 to 0, and then it goes from 0 to +1, the slope of this payoff line. Anyway, and below 40, we also bought a put option with strike of 40, the first one listed, but the last one I'm talking about, and that's going to take the slope from +1 to 0. So this is what the payoff diagram looks like. Looks like kind of a little hat. And then also we know that the cash flow, we paid 7 for the first. We sold the second. We sold these two puts for 8 and 9. Then we bought one for 11. Our net cash flow at time 0 is 1. No interest rate is listed, so assume the interest rates are 0, which makes things relatively easy. So we have to shift our entire to find the profit. We would have to subtract 1 from everywhere on that graph. So that's why I have the -1 there. So just shift it down by 1 everywhere. So from 0 to 40, we have a slope of 0. Oh yeah, payoff of a profit rather of -1. It's a negative profit, and then it goes up to 4 between 40 and 45. between 45 and 50, it's 4. It stays there. Between 50 and 55, it goes from 4 to -1. And then above 55, it's flat at -1. So there's our profit diagram. If it's below 40 or above, if the stock price S at expiration is below 40, then our profit is -1. It's a $1 loss. And here this just, and then it's going to max out between 45 and 50 at 4. And then if the stock price ends up above 55, then again we have a $1 loss. So this is just going to profit between 41 and 54. The break-even points are 41 and 54.